Okay, so in this problem, we are now going to be seeing how we are going to be determining the limiting reagents or the limiting reactants using the mass method. Okay, so if you want, feel free to pause the video and then just copy this, or if you want, you can be going just step by step with me. Okay, it's going to work. It's going to be very much fine. So, according to the question, they're saying that magnesium oxide reacts with dilute sulfuric acid as shown below. Okay, so this is the balanced chemical equation for this reaction. Okay, again, have you seen that there is dilute there? So we're not going to focus much on that. But like I'd said in the previous video, there is a distinction that is there between dilute sulfuric acid and concentrated sulfuric acid. So magnesium oxide is reacting with sulfuric acid. Again, this reaction is a neutralization reaction. Okay, it's a neutralization reaction. And one thing that you need to know is that neutralization reactions are exothermic in nature, in the sense that anytime they are taking place, there is always some heat energy, a lot of heat energy that is going to be released during the process. So neutralization reactions are exothermic reactions, and the heat which is released is referred to as the heat of neutralization. Furthermore, you're going to see that there is water that is going to be released along the way. There are water molecules that are going to be released as the reaction is taking place. So this neutralization reaction is not only just exothermic, but it can also be termed as a condensation reaction. The reason why we're going to be referring to it as a condensation reaction is because there are water molecules that are being released, that are being produced. So just have that in mind. Time is going to come where we will explain these things in much more depth. So 600 grams of magnesium oxide reacts with 980 grams of sulfuric acid. 600 grams of magnesium oxide reacts with 980 grams of sulfuric acid. The first question is determine, so it's not exactly determining, that was just a writing error. It's determine the limiting reagent in the reaction above. So in order for our mass method to be applied here, the first thing that we can do is that we can write a balanced chemical equation for that same reaction. The same equation that has been given, you write it back again. But this time you should ensure that it is balanced. Okay, not just a copy and paste thing whereby you just write the way it is like that. No, you need to ensure that your equation is balanced. So notice the equation here. If you compare, you're going to see that your equation is already balanced, so there is no need for us to start making any comparisons. Here it's just balanced. Okay, there is one magnesium, about five oxygens, um, two hydrogens, one sulfur. I mean, it's already balanced, so we don't need to waste much time there. Okay, we don't need to waste much time there, so you need to ensure that it is balanced. Now, this is how the mass method can proceed. What we do is that we get the reactant and then start pairing them up with any product of our choice. Like in this case, the magnesium oxide was first paired up with magnesium sulfate. And this is how I have written it. Magnesium oxide, magnesium sulfate. The second step is that you now need to start determining their molar masses. The molar mass for magnesium oxide, how can we determine that? Well, magnesium, according to our periodic table, magnesium has a molar mass of 24 grams per mole. Oxygen has a molar mass of 16. That's the whole reason why I've just seen me write 24 plus 16 directly. Okay? When you're talking about your magnesium sulfate, magnesium, yes, 24. Sulfur on your periodic table has a molar mass of 32. That's the 32 you're seeing me right here. Oxygen, like I've said here, has a molar mass of 16. But if you pay attention, or if you look closely, you're going to see that there are about 4 oxygen atoms present here. So it would be very, very wrong for you to just write 16 because there are 4 oxygens there. So it's supposed to be 16 times 4, which is going to give you 64. Hence, writing this is going to be 24 plus 32 plus 64. And of course, the grams per mole unit should also be followed up. If we sum them up, 24 plus 16 is just going to be 40 grams per mole. 24, 32, 64, if you sum them up, your value is just going to be 120 grams per mole. Once you establish their relative molecular masses or their molar masses, once you write them up, remember, the mass of magnesium oxide has been given. It was 600. So you get that same value and then you're just going to put it there. You don't know the mass of magnesium sulfate, so you just put X. If we begin to cross multiply here, this is just going to be 600 multiplied by 120. That's what you see here. 40 will be multiplied by X, so it's like you're going to have 40X here. And then if you divide both sides by 40, this is the expression that you're going to have. It's going to be 120 multiplied by 600 divided by 40. And the value, if properly evaluated, the value is going to be 1,800 grams of magnesium sulfate. So 120, 600 divided by 40, this is just going to be 1,800 of magnesium sulfate. Once you pair up the magnesium oxide with the magnesium sulfate, you're now going to pair the sulfuric acid with the magnesium sulfate. This is the whole reason why you're seeing me write sulfuric acid with the magnesium sulfate here. Again, same thing, you're going to determine their molecular or their molar masses here. The molar mass of sulfuric acid can be determined as follows. Notice how is it that there are 2 hydrogen atoms here, and hydrogen has a molar mass of 1 gram per mole. So 1 times 2 is just going to give you 2. Plus sulfur is already 32. Oxygen is going to be 64. There are 4 oxygen atoms. So 4 times 16, 64 grams per mole. If we come with the magnesium sulfate, I mean, we had already done this. 24 plus 32 plus 64. I mean, you can choose to re-evaluate it, or if you want, you can just get the same value, the 120 grams per mole that you had found, and then you just bring it back. But for the sake of just being systematic, we can just write it again. So the value is just going to be 120 grams per mole. Okay, so here, notice 98 grams per mole, 120 grams per mole. We're having 980 grams. So what can be our value of X? So if we choose to be fast in this way, you're going to see that this is 98. There is a 980 there, which means that if this is 120, if we add another 0, this is going to be 1,200 grams. That's going to be your X value. Okay, so 98, you just add a 0, that's the 980 we're seeing there. So if this is 120, if we just add a 0 at the end, it's going to be 1,200 grams. I mean, if it's too confusing, you can just choose to cross multiply. You're going to have 980 times 120 divided by 98. But again, you're just still going to find yourself at the 1,200 grams that has been here. So we're having 2 values of the mass for magnesium sulfate. There is 1,800 grams of magnesium sulfate here, and there is also 1,200 grams of magnesium sulfate. You used magnesium oxide to determine this mass. You used sulfuric acid to determine this mass of magnesium sulfate. Same here. Now, if you recall, just to take you back a little bit, in the previous video, notice how is it that when we were using the mole method, we had used the number of moles of magnesium oxide to find the number of moles of magnesium nitrate, and we noticed that the value was 0.075. Again, we had also used the number of moles of nitric acid to find the number of moles of magnesium nitrate, which upon answering, evaluating, we saw that the value was being given as 0.04. And we noticed that the 0.04 moles here was being obtained from the nitric acid. And because of that, we termed nitric acid to be our limiting reactant, because it was the one that was giving us the least number of moles of magnesium nitrate. So nitric acid here was termed as our limiting reactant. Magnesium oxide here was termed as our excess reactant. Why? Because it's the one that was producing the higher number of moles of magnesium nitrate, which was 0.075, and for that reason it was the excess reactant. Applying the same concept here, you're going to see that magnesium oxide was producing a higher mass of magnesium sulfate as compared to sulfuric acid. Just look at it. Sulfuric acid was producing about 1,200 grams of magnesium sulfate, a value which is smaller than that of the magnesium oxide. So for that reason, just like I had shown you under the mole method, the same thing is also going to be applied under the mass method. Magnesium oxide is going to be termed as our excess reactant. Magnesium oxide. Why is magnesium oxide our excess reactant? Because it's producing a higher mass of magnesium sulfate. So it's going to be the excess reactant. Sulfuric acid, on the other hand, was producing about 1,200 grams of magnesium sulfate. So because it's producing the lower value here in terms of mass, you're going to see that sulfuric acid is the one that is going to be your limiting reactant, your limiting reagent. So that's it. That's how you can use the mass method to determine your limiting reagent. Basically just comparing or getting the reactants given, their masses, and you just evaluate them in the same way as I have done. So sulfuric acid is going to be our limiting reactant. I hope that's understood. Now, this is not the only question that you can be given. Okay? This is not the only question that you can be given. You can be asked a question to determine, okay, the mass of the excess reactant which was used. You can also be asked to calculate the mass of the excess reactant which was used. So there are two methods which you can use when determining the mass of the excess reactant which was used. You can proceed with the mass method. Sulfuric acid is the limiting reactant, so you get it. Magnesium oxide is the excess reactant, because that's what they said. Calculate the mass of the excess reactant. So you couple the limiting reactant together with the excess reactant in this way. Sulfuric acid is going to maintain its mass, which is 980 grams. Why? Because it's been completely used up in this chemical reaction. So it's still going to be 980 grams. Nothing is going to change. The mass of the excess reactant, magnesium oxide, we don't know it. So it's just going to be X. Again, you establish their molar masses. The molar mass of sulfuric acid was already established. That was 98 grams per mole. Nothing has changed. The molar mass of magnesium oxide is 40 grams per mole, just like we had established in the beginning. Again, nothing has changed. So upon doing that, notice 98, 980. So if this is 40, then our final answer is just going to be 400. That is if you just choose to go in a very fast way. But you just have to show them. So it's going to be 98 times x equal to 980 times 40, and then after you evaluate, the value is just going to be 400 grams of magnesium oxide. So this is the mass of magnesium oxide that was used. Originally, the mass that was given for magnesium oxide was 600 grams. So what this entails is that out of the 600 grams that was available, only 400 grams of magnesium oxide has been used. This is what this means. Out of the 600 grams of magnesium oxide that was available, only 400 grams has been used. It is for this reason that they may not only just ask you, maybe say, to calculate the mass of the excess reactant which was used, but they can ask you to calculate the mass of the excess reactant which had remained. So if you are trying to calculate the mass of the excess reactant which had remained, like in the case of the magnesium oxide, it's just going to be the original mass minus the used mass. So it's going to be 600 minus 400, which is now going to give you 200 grams. So original mass is equal to used mass plus remaining mass. So you can just write this formula down somewhere. Original mass is going to be equal to used mass plus the remaining mass. So if you are trying to calculate your remaining mass here, it's just original mass 600 minus 400 grams, your used mass. Okay? So this is just the first method, your mass method. I hope it's not that confusing. For the second method, you can calculate the number of moles of sulfuric acid. Number of moles is equal to mass over molar mass. Remember this formula? In the previous video, we had already established this. Number of moles is equal to mass over molar mass. The mass of sulfuric acid, again, why am I getting sulfuric acid? Because sulfuric acid is the limiting reactant. The value here is 980 grams. That is what was given. The molar mass for the sulfuric acid is 98 grams per mole. If you divide these values, you're going to see that the number of moles of sulfuric acid is just going to be 10 moles. Okay, so 10 moles of sulfuric acid is what was used overall in this chemical reaction. Okay, now once you find the number of moles of sulfuric acid, we can use the same number of moles of sulfuric acid to find the number of moles of the excess reactant, which is your magnesium oxide here. How? If we compare or look at it from the balanced chemical equation that we have already established here, you're going to see that the mole ratio between the magnesium oxide and the sulfuric acid, the mole ratio is just 1 to 1. So in other words, 1 mole of sulfuric acid was reacting with 1 mole of magnesium oxide. And remember, if the number of moles are the same here, that is 1 to 1 in this way, if the mole ratio is 1 to 1, then the number of moles of sulfuric acid and the number of moles of magnesium oxide are going to be the same, they're going to be equal. So if we had 10 moles of sulfuric acid, then we're also going to have 10 moles of magnesium oxide, because the mole ratio is strictly 1 to 1. Once we find the number of moles of magnesium oxide, remember, the number of moles and the mass are being related in this formula. That is, number of moles is equal to mass over molar mass. So if I want, I can choose to make my mass the subject of the formula. Upon making the mass the subject of the formula, this is going to be mass is equal to the number of moles multiplied by the molar mass. The number of moles of the magnesium oxide here is just 10. Like we have established, it's just 10. That's the 10 there. The molar mass for magnesium oxide is 40. So this is going to be 10 times 40, which is still going to give us 400 grams of magnesium oxide. So this is the mass way. We're having 400 grams. This is the mole way. We're still having 400 grams. So you can choose a method that is easier for you. So that's how you can find the mass of the excess reactant. And like I've explained, this is also how you may proceed when you are determining the mass of the excess reactant which had remained. you first need to find the mass which was used. Upon finding the mass which was used, you can be able to now determine the mass which had remained, which in this case, the mass of the excess reactant which is going to remain here is just 200. 600 grams minus 400 grams. The original mass minus the used mass, and that's going to give you 200 grams. Okay, 200 grams. And then another question maybe which can be given might be for you to calculate something which we call the percentage yield. So another question can be given, say, given the actual mass of magnesium sulfate produced is 800 grams, calculate the percentage yield. Given the actual mass of magnesium sulfate produced is 800 grams, calculate the percentage yield. Now, percentage yield is given by the formula actual mass or actual yield over theoretical mass or theoretical yield. Okay, so actual mass or actual yield over theoretical mass or theoretical yield. Of course, this is going to be multiplied by 100%. We don't have a problem with the actual mass. It's 800 grams. But how can someone be able to determine the theoretical mass here? There were two values that we had found for the magnesium sulfate. There was this 1,800 grams and there was this 1,200 grams. These values are all theoretical masses, but we tend to choose the one for the limiting reactant rather than for the excess reactant. So you're going to pick that of the limiting reactant rather than for the excess reactant. Okay, so that's the 1,200 grams that you had found. So this is the 1,200 grams that we should put here. So 800 over 1,200 multiplied by the 100%. If you punch these things in your calculator, and of course rounding off to 2 decimal places, your value is going to be 66.67% of magnesium sulfate. Okay, 66.67% of magnesium sulfate, and that is it. Okay, now notice there is also something that I want you to take note of. So take note, that's how it goes. I hope you are very much clear. So actual mass 800 grams, your theoretical mass is that one for the limiting reactant, the one that you had used, that one that you had found using your limiting reactant rather than for the excess. So 1,200 grams. So you just pick the smaller one. That's the one which we had used here, and that is it. So I'll just run it through one more time for the sake of understanding. And then for this one, look, we have determined our limiting reagent, we have determined our limiting reactant. A question can be given to say, find the mass of the magnesium sulfate produced, or calculate the mass of the magnesium sulfate produced. So, if you want, you can just rewrite these same things again. In case whereby after being asked to calculate the limiting reagent, determine the limiting reagent, and then another question comes to say calculate the mass of magnesium sulfate produced, if you want, you can rewrite the same thing, because if you notice, this was part of the procedure in determining our limiting reagent. So if you want, you can just rewrite the same things again. But again, of course, just to avoid repetition, this is not the only way. You can calculate the mass of the magnesium sulfate using your limiting reactant. This is also another way. That was the mass way. This is now the mole way. How? You can start by finding the number of moles of sulfuric acid, like we had done. So number of moles is equal to mass over molar mass. 980 grams over 98 grams per mole. Our value is just 10 moles. We have already established that. Look at it. the more ratio between your magnesium oxide and your magnesium sulfate, the more ratio between the two is 1 to 1. 1 mole of sulfuric acid is producing 1 mole of magnesium sulfate. So again, 1 to 1 implies that the number of moles of the sulfuric acid and the magnesium sulfate are the same. So if we're having 10 moles of sulfuric acid, then we are definitely going to have 10 moles of magnesium sulfate. Like we had already established, remember we're trying to find the mass of the magnesium sulfate using our limiting reagent. The mass and the number of moles are related by this formula. So if we make the mass the subject of the formula, this is going to be mass is equal to number of moles multiplied by your molar mass. Your number of moles is 10 for the magnesium sulfate. The molar mass for the magnesium sulfate is 120. And again, 10 times 120 is just going to give you 1,200 grams of magnesium sulfate. And afterwards, that's it. This is going to be your mass of magnesium sulfate. So, like I told you, in a case whereby you have been asked to do the same thing again, to find the mass of magnesium sulfate, despite you using this same procedure, the mass way, you can copy the same things, rewrite it again, there is no harm. Or if you just want to avoid repetition, in case maybe you're having some insecurities that maybe they might make me wrong, this is another way. Okay, this is another way. So this is how questions can be at least given on determining your limiting reagent. So I hope this video is going to be of greater help. Okay, so I hope it helps. Thank you very much for watching, and please don't forget to subscribe.